rate of change, slope and rate of change. We're going to learn in this unit as well that slope is not only just the growth on a graph or growth of a line, but it's also the rate of change for a particular quantity. Examples of that might be miles per hour, price per pound, calories per serving, etc. This is what really relates what we're doing with graphing lines to some real world applications and utilizing slope or understanding slope as a rate of change. Interpreting rate of change from an equation, a table, a word problem, and a graph is what we're going to take a look at in this video. First, from a table, what is the rate of change with the slope from each table below? Sometimes this is really easy because I can look at the table, and if my x values are all changing by 1, okay, they're all growing by 1, I can look at the y values and determine what they're growing by. This takes us back to our discussion on sequences. If I was looking at this, I would try to look at and see how this is growing each time. This one goes down 3, then down 1, and then up 1, and then up 3. So right away I can look at this rate of change and determine that this is non-linear, okay, because it's not the same change each time, and that could happen. Okay, next I want to take a look at this one here. I notice as my x values are changing by 1 each time, my y values all stay 3. So this has no growth or no slope or slope of 0. So the rate of change is 0. The slope would be 0. That would end up being a horizontal line if I graphed it. My next table is a little trickier here. I notice that some of my x values aren't changing by 1, but then I get some that are changing by 1. So the idea here would be to find those and verify what this is growing by. So if I take a look at this, I see that from 4 to 1 is -3, 7 to 4 is -3, 1 to -2 is -3. So I notice that my pattern here is -3. So the rate of change here would be -3. It's going down by 3 each time. And finally, I have a table here which none of my x values are counting by 1s. Okay, so it's a little bit more challenging. Oh, there, I did find one. 10 to 11 goes up 2. But I need a way to verify that. So if I look at, let's say, 2 to 4, so x changes by 2, y changes by 4. Okay, so if I made a proportion out of that, if my x values, when they change by 2, y changes by 4, I want to know what my x values change by when my y values change by 1. Okay, so 2 and 4 makes 2, so plus 2. So my rate of change here, okay, is 2, plus 2. All right, so that's how I would determine slope from a table. Next, what about an equation? Okay, so if it's an equation, I'm trying to determine the rate of change. I'm looking for the m in the mx plus b. All right, and in this case, my rate of change is 3, plus 3 to be exact. And this is a little bit more of a real life example. I have the 35t plus $50. The $35 is my rate of change. This one here, I do not have y by itself, so I would have to get y by itself. So 10y equals 30 minus 5x. So I'm subtracting a 5x on both sides. All right, I divide by 10. So I get y equals 30 divided by 10 is 3, minus 5 divided by 10 is 1/2 x. So which one of those is my rate of change? It would be the number with the x. So my rate of change here would be negative 1/2. And finally, what if I have a graph and I'm trying to interpret rate of change? I need to pay special attention to the units, what they're counting by. I cannot just count blocks. Kindergartners count blocks. So if I label my slope triangle or growth triangle here, this will be up 5. And this is counting by 20, so it's over 40. So if I make my growth triangle here, I would have 5 over 40. If I reduce that, I'll get 1 over 8. And what are we talking about here? We're talking about centimeters per gram. Okay, because centimeters is the rise, grams is the run. All right, and if it does have a label, then you must label. Here my blocks are counting by 100s, and these are counting by 10s. So I want to try to look at this here and determine what it's going up each time by. Looks like it's a little more than 100. So if I count all the way from 0 to 500, that'd be 500 up. And then it goes over 40, so 40 over. So my rate of change is going to be 500 over 40. If I reduce that, the zeros cancel. 50 divided by 4 is going to be the same as 24 over 2, or 25 over 2. I could write it as a 13.5 if I wanted to. That's a 12.5. Come on there, Ms. Warner. And again, my label is going to be calories per fluid ounce. That's an important one, all right, for the soda drinkers out there. And last, I have this particular graph here. Again, I'm trying to find two values where it actually touches, okay, the grid line. So there it's rise 200, and here I'm counting by ones this time, so it runs 5. So I have a rate of change of 200 over 5, which equals 40. What is the units? It would be miles per hour, and that should be a unit that we're familiar with. And that's it.